Hello. If you're asked to solve this math question, x to the power of the square root of x equal to 3, you're asked to find the value of x, what will you do? Wait, don't rush over it, because a lot of persons fail this kind of question, so be careful. What can we do in order to solve a question like this? Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more unique maths content. Now, to solve this question, we need to look at how we can apply some rules of mathematics in order to solve it carefully. Now, let's look at this. We have x to the power of the square root of x. Now, if we have x to the power of the square root of x, I want you to look at something that x can be equal to, if I have the square root of x square, can still give me x, right? Because x can still cancel out square root of x square root, and the square can still cancel out square root, and then x will be equal to x. So that tells me that square root of x square can simply replace x. Now, I'm going to apply that in that expression. Now, instead of having x, I'm going to have the square root of x square, right? And all of these will be what? Will be to the power of the square root of x. How about this? I think this will work better in solving this question. Great. Now, in the next step, I'm going to simplify. Applying the law of logarithm, you'll find out that if you have a to the power of x multiplying y, the rule of logarithm indices says the index will have to what? To multiply. So that will now give me the value of the square root of x to the power of 2 multiplied by the square root of x. And this will be equal to 3. Great. Now in the next step, what do I do? Having gotten to this point, I will now have to simplify this expression. Now, to simplify this expression, let me assume that my square root of x be equal to y. Now, take note of this is going to be essential as we solve this question. If I assume my square root of x to be equal to y, that expression will automatically change because the expression will now become y to the power of 2y, right? And this will be equal to 3. So what do we do from here? The next thing we need to do in the next step is to apply the laws of logarithm. Yes, logarithm can solve this question. Now let's look at taking the natural log of both sides. If I take the natural log of both sides, I'll have the natural log of y to the power of 2y equal to the natural log of 3, right? Now, if I do that, I'm going to simplify this. Now, recall the law of logarithm that if you have the natural log of a to the power of x, this can be equal to x multiplying the natural log of a, right? Good. And that's the rule in indices, in logarithm. So we'll have 2y multiplying the natural log of y, and this will be equal to the natural log of 3. Great. Now, what do we do next? In the next solution, let's see how we'll simplify this by dividing both sides by 2. If I divide both sides by 2, normally 2 will cancel out 2, and I will be left with y multiplying the natural log of y, and this will be equal to the natural log of 3 divided by 2. Great. Now, in this next case, I'm going to apply some rules of indices and logarithm. Now, having divided both sides by 2, now we'll have to recall that in logarithm, if I have this expression, uh, the exponent of the in of a value. Let's say the value is y. This can definitely give me what? Y. It will give me y. And that is a rule in what? In logarithm. I have to take note of that. So that means this y, I can simply replace that y with the exponent of in of y. So if I do that, I'll have this to become the exponent of in of y multiplying the in of y, and this will be equal to the in of 3 divided by 2. Great. Now in the next step, I'm going to expand that. That will give me the in of y multiplying the exponential value of the in of y, and this will be equal to the in of 3 divided by 2. Good. Now at this point, what do I do? At this point, I'll look forward to applying a Lambert W function. Now, what does the Lambert W function says? The Lambert W function states that if I have the Lambert of a value a multiplying the exponent of that value, that this can simply be equal to that value, right? And recall that from this expression, my a is equal to the in of y. Now take note of that. My a is like having the in of y if you look at that expression very well. So if you compare that Lambert expression with that my expression, you'll find out that that expression will now give me the Lambert. If I take the Lambert of both sides, that will now give me the Lambert of in of y multiplying the exponent of in of y, right? And this will be equal to, I also take the Lambert function of the in of 3 divided by 2. Great. Now, if we simplify this according to Lambert, this will only give me the in of y, right? And this will be equal to the Lambert of in of 3 divided by 2. Great. Now, having arrived at this point, I'll now look at how I'll make good use of the exponent value. Now, recall that if I take this to become the exponential value of in of y, I will also do this to the right hand side, exponential value of the Lambert of in of 3 divided by 2, right? Now, if I do that, this expression, remember what we did, this expression can simply give me what? Y. So if that expression give me y, I'll have my y to be equal to, do you recall that we said that that expression can give me y from this expression we have here? If you recall that. Now let's go back to that expression. The exponent of e of y will give me y, and this will be equal to the exponent value of the Lambert of in of 3 divided by 2. Good. So if you simplify this, you're going to recall something. Recall from this expression that we had our y covered. How did we have our x and y covered? We said the value of square root of x is equal to y. So if the value of the square root of our x is equal to y, recall that's exactly what we have, and we have our y to be equal to this. We had the square root of x, we say it is equal to y. So that simply tells us that our x can be equal to y what? Y square. So that simply tells us if x is equal to y square, we'll have that expression to now give us x equal to y squared, and since this is also squared, this other one, the exponent of the Lambert of in of 3 divided by 2 all to the power of all divided by 2. This will also be what? This will also be squared, right? So if we have that expression to give us that, that is the value of y. Now, if that is the value of y, then the value of our x is if the square can clear off the square, or if we have this expression, the value of our x can now be equal to, simplifying this, we can have this to become the value of uh, e to the power of 2 Lambert, right? And this will be multiplying the in of 3 divided by 2. And that is what that expression will give us. So this is going to give us the solution to that expression. Or if we simplify this using our calculator, the in of 3 divided by 2, the 2 Lambert, finding the Lambert of the in of 3 divided by 2 and multiplying it by 2, the value of our x will be equal to approximately 2.125, and that would be the solution to that expression if we're simplifying it to the latest. Now, I want you to test if this solution is actually right. Take the value of x, substitute it into the original expression, and see if you will have 3. Point your calculator. If that gives you 3, let us know in the comment section, and we'll be glad to engage you. Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Thanks so much for watching, and bye bye for now.